And the next thing I want to prove to you is that e to the x is bigger than 1 plus x squared over 2. So how do I do that? I introduce a function g of x, which is e to the x minus this. And now I'm just going to do exactly the same thing I did before, which is I get started with g of 0, which is 1 minus 1, which is 0. And g prime of x is e to the x minus, now look at what happens when I differentiate this. The 1 goes away, the x gives me a 1, and the x squared over 2 gives me a plus x. And this one is positive for x greater than 0 because of step 1, because of the previous one that I did. All right? So this one is increasing. G is increasing, which says that g of x is bigger than g of 0. And if you just read that off, it's exactly the same as our inequality here. E to the x bigger than 1 plus x squared over 2. Now, you can keep on going with this essentially forever. And let me just write down what you get. You get e to the x is greater than 1 plus x squared over 2. The next one turns out to be x cubed over 3 times 2, x to the 4th over 4 times 3 times 2. And you can do whatever you want. You can do others. And this is like the tortoise and the hare, right? This is the tortoise, and this is the hare. It's always ahead, but eventually, if you go infinitely far, it catches up. So this is the act turns out to be exactly equal to e to the x in the limit. And we'll talk about that maybe at the end of the course.